Welcome. In this video I'm going to show you how you can perform a Pearson Chi-Square Goodness-of-Fit test using Python and my library stikpetP. I'm using Jupyter Lab and I'm running Python version 3.11 by now, but it should work on most versions of Python 3. This video will focus on how to actually obtain the output, not so much if you should be using this test at all. Perhaps you should be using a different test. I'm also not going to explain too much on how to interpret the output. It's just about getting the output and mainly the p-value. To show you this, I'll need an example data, so let me load in pandas SPD and then load a file called GSS2012A, which is a modified version of the General Social Survey. I don't need all the data, I just need a nominal field, so let's be using the marital status for that. And to show you a quick impression of that field, the frequencies. So for example, 314 people indicated that they were divorced. Now my library cannot be installed by just using pip install and then the library name. It actually only hosts on my my GitHub account, so please use pip install and then the GitHub link. After that, you can import it just as any other library, and I'm going to import it as PS. The function of interest, the TS Pearson Goodness-of-Fit, takes as input parameter the data, which should be a pandas series. You have optionally to add the expected counts that you want to use, and if you like, you can apply continuity correction. So I've loaded everything in. I just feed the function my data, and it spits out a nice data frame with the sample size, the number of categories, the chi-square statistic value, the degrees of freedom, the p-value, also known as the significance, that also shows the minimum expected count. I didn't provide it with expected count, so it simply takes the sample size and divides it by the number of categories and uses that for the expected counts. And since it's then the same for all categories, the minimum is also that. The proportion of cells with an expected count below 5 was 0%, and a small description of the test that was actually used. If that p-value is below 0.05, we usually then reject the assumption, and in this case we would say then that not all categories were equally often chosen or significantly not equally distributed. If you like, you can also add a continuity correction, so for example the Williams correction, and then it shows a slightly different result because the sample size is fairly okay. And the test description of course also adjusts. I have a separate video on how you can do this, for example with SciPy, so if you don't want to use my library, or if you want to do it the hard way by going actually over the functions or the formulas. It then still needs the chi-square distribution. If you don't even want to use that, I have some separate documentation on how to do that. These were the appendices, the references, and in the appendix I show a little bit more detail about those different corrections. Note that the Yates is usually recommended only if you have 2 degrees of freedom. And I think that's about it. I hope this video was helpful, and thank you for watching.